Good morning, everybody. This is Cloud, Single Sign-On, and Integration. My name is Scott Morrison. I'm talking to you from an early morning in Vancouver, British Columbia. It is a dismal and rainy day here, so I hope wherever you are, the weather is a little better than it is around here. Seems like only a few days ago I was sitting on a beach in Cyprus in the Mediterranean, 26 degrees, and it was beautiful, and not a cloud in the sky. But of course, for the rest of us right now, there's a lot of clouds. And that's exactly what we're going to be talking about here. How you can actually get out there and start to make use of this new technology, cloud computing, and how to actually integrate it effectively into your existing IT department. Cloud doesn't mean the IT department's going away. Cloud is actually about new opportunities. It's about actually leveraging a new kind of technology, a new way of delivering IT that can entirely coexist with all of your existing investments that you've already put a tremendous amount of money in. And that's exactly what we're going to talk about today, how you can actually utilize your existing technology and actually be able to integrate in with some of the new cloud technologies that are coming out today. So, in any kind of story like this, of course, we've got a bunch of players, a bunch of actors. And so let me introduce them quickly. The first one, of course, you know very well, and the starring role in this whole thing is really the legacy app. This is your mainframe, your database. These are your mission-critical technologies that you've already got. You've spent a tremendous amount of money maintaining these over the years and keeping them going. And I'm here to tell you today that despite the fact that cloud computing is promising to revolutionize a lot of IT, the legacy app isn't going away. This is one star who has a lot of legs and is going to be around for a while. So the big question then is, how can we make the legacy app, how can we make this thing that is mission critical, that is a part of your organization today, that you can't actually get rid of, that you don't want to get rid of, how can we actually make that very relevant in a world of clouds? And really, that's a lot of the talk of what this talk is about. This is fundamentally really about the use of the legacy app in cloud environments. So of course, that is the fundamental starring role. That is the primary billing of today's talk right here. But of course, another important piece of technology, another one that we can't really forget about, is the existing identity stores that you've got. It doesn't matter what they are. This could be Active Directory. This could be a generic LDAP directory that you've got. This could be the identity and access management system that you've been carefully developing over the last 10, 15 years or so. Maybe it's Tivoli. Maybe it's Oracle. It doesn't really matter. The fact is, though, that you've got a tremendous investment in your people and their representations in this particular piece of technology. So the big thing that you've got to consider is not just how you start to leverage the legacy app out there in the cloud. The big question you've got to consider is how you can take this other critical data source, this critical data source that talks about your people, your human resources, and how you can start to actually leverage that out in clouds as well. So this is another starring role. It may be second in my billing, but the truth is, in all of our lives in IT, this is probably the one that we use certainly every day, first time in the morning when we get down and sit on down at our desktops and actually sign on. We're talking to this particular piece of technology, and so we want to be able to leverage it out there in the clouds. Now, of course, co-starring roles are you and I, the people that are actually browsing out there on the web and actually starting to make use of these cloud technologies. The interesting thing about the pattern of how we use cloud is the very first kinds of applications we use out in the cloud tend to be browser accessible. And they tend to be the kinds of things that are actually like, well, websites, frankly. But the truth is, they're actually, if you look at the architecture of how these things have been put together, they're actually fundamentally different than the classic websites of, well, 10 years ago or so. And so we, as the people who are using cloud technologies right here, using browsers to access them, are a very important part of this whole story. And so, of course, we can take that co-starring role. And the new person, the new kid on the block, the new actor that we've got to talk about here is really the cloud, which when you think about it is really one of these incredibly amorphous terms. Cloud is one of these things that we hear about a lot, but in a lot of ways we're not really sure what it really means. And so part of what I want to talk about in the beginning of this talk is really try to disambiguate a lot of what cloud is about. Because every one of us hears these stories about how cloud is going to revolutionize IT, how we're actually going to convert from OpEx to CapEx and things like that. But one of the big problems that we run into again and again and again, and that is fundamentally that people are misrepresenting what cloud is really about. So here's what I actually want to do. Here's the thing that I actually want to talk about to everybody here, which is what are the really key characteristics of cloud that I think are fundamentally very important. And I'm going to take the lead actually from the National Standards Commission, which has actually gone through and sort of said cloud is not something you can define in a very, very concrete manner. But in fact, you can define it best by looking at a collection of attributes. And cloud may have all of these, or it may only have a few of them. But depending on how many it picks up, you can figure out if it's a cloud or not. So let's kind of walk through these. And I'm not going to use the NIST version particularly. What I'm going to do instead here is I'm actually going to talk about a lot of other characteristics that are sort of fundamental ideas, attributes that begin to make up what cloud is really about. So here's a first example, Internet accessible. And this is one of those things that at first people will sort of scoff and say, well, God, everything's Internet accessible. But is it really? Are your applications that you're using every day in your IT department, are they really Internet accessible or intranet accessible? Can you get access to them from Starbucks? Do you have to fumble around with a VPN and get that up and going and make sure that that's working to be able to access your applications? Internet accessible, of course, just means that depending on where you, or regardless of where you are, regardless of whether you're sitting at your desk in your existing enterprise, or you're out at Starbucks, or you're out at the lounge waiting for an airplane, you can get access to these things. There's a certain idea of a democracy of access here. And furthermore, it's not just about how you access it. It's about the kind of devices that you can access it with. It'd be neat if I could stop and get an idea of how many people are actually watching this thing that have iPads, for instance. I think the iPad is a really interesting new piece of technology. And the reason is because it's the third device. We all have web browsers, of course, and we've all got smartphones by now. But the iPad was interesting because it actually created this third device that you couldn't necessarily draw a line and intersect between the browser-style device, in other words, the laptop or desktop, and a smartphone, which we started to build websites to accommodate in that. All of a sudden, we've got this interesting third form factor. And with that, we suddenly realized that that's only the beginning. Whereas over the last few years, we've been starting to build our websites more and more so that they could deal with just those two extremes, the extreme of the smartphone and the extreme of the conventional web browser. Now all of a sudden we've realized that there's going to be this explosion of different form factors. And so one of the key things we've got to think about in our technologies, and in particular technologies that are developed so that they can be accessed from anywhere, is the fact that these systems are actually going to have to be accessed by a whole diverse range of different form factors, of different display capabilities, of different input capabilities. And that's a major rethink, really, in how we're actually going to build our applications. We can't just get away with simple transcoding and things like that we got away with before. We actually have to rethink how we're actually delivering services fundamentally. It may not be as simple as just creating a web page that can be banged and morphed and bent into the shape of whatever form factor you've got. You may actually have to take fundamental services and make those accessible to all sorts of different technologies. And that means it may not necessarily be a web browser at the other end. Here's another characteristic that we see in cloud, and that's the idea of low barrier to entry. And in a lot of ways, I think this one is really fundamental, because cloud is about getting out there and getting access to the technology very, very fast with very, very little, friction. In other words, you can get out, whip up your web browser, be out on a cloud site within moments, pull out your credit card, actually be signed up, and within 5 minutes or so, actually be using cloud technologies. Now think about how profound that is. Think about how different that is from what you've been doing in IT over the years, where you have to fill out forms in triplicate, go out and provision systems, get them plugged into your network, wait for firewall holes to be opened up. In other words, all those kinds of little things, which don't seem like much, but taken as a whole, add up to a very, very slow deployment. Really, cloud is about an agility in operations. It's an agility about provisioning and actually getting applications out there extremely fast. And furthermore, enabling people to actually start to operate their applications regardless of what their actual role is. There's a whole new movement associated with cloud called DevOps, where the developers, the people who are actually putting together the applications themselves, are actually taking a surprising amount of responsibility for actually operating them as well. And the reason they're doing this is because, number one, they're kind of the stormtroopers in this whole idea of cloud technology. They're the first people to actually start to use it. And so logically, in any new technology like that, they have enough time invested into it and understanding of the technology. They're a very logical group to actually be working on this kind of thing. But furthermore, they actually fundamentally are enabled to do the operations, which is something that in general they haven't been able to do before. The fiefdoms that we've created in IT, in a lot of ways, actually stand in front of agility. Whereas cloud, because it's just so accessible, because it's democratizes access so that anybody can get to it, it actually opens up a lot of the day-to-day operations to actually the people who know the application best, which in general are the developers themselves. Now, is this a long-term trend? Probably not, because fundamentally, as you start to get past, the one-offs and the quick, interesting new deployments, developers don't want to be involved in the day-to-day operations of applications. But the truth is that early on, they're actually essential in that kind of thing. And the fact that they can do that is actually a really, really important new idea in cloud. Now, on-demand is this concept that really, as you need compute capacity, whether it's, let's say, CPU, memory, storage, network, whatever, you can draw it in. What if you think about scaling and the idea of being able to expand out really fast and be very responsive in terms of getting access to more technologies and more capacity? What if, let's say, you're an e-commerce site, and you're selling, I don't know, some kind of widgets or dolls or something like that, and that most coveted demographic around suddenly decides it's interested in one of the things that you're selling, let's say some kind of interesting doll. And what's that most coveted demographic? Teenage Japanese girls. If teenage Japanese girls suddenly decide that they're fascinated with whatever it is you're selling, all of a sudden you can get this incredible flood of business. It's the kind of thing that people in e-commerce both dream about, but also in a way dread, because all of a sudden it can mean within a few days you've got this tremendous flood of interest in your object, your thing that you're trying to sell. And so the big problem that you have to ask yourself, let's say as an architect going into some kind of e-commerce system, is have I provisioned enough capacity at the very beginning so that I can deal with those kinds of spikes? If all of a sudden one very fast-moving demographic that gets very fascinated with things in a very, very short period of time, all of a sudden descends on what it is I'm selling. If I create that fad around what it is I'm selling, can I actually deal with it? Or else do I go down in flames with systems that actually aren't responsive, that can't actually handle the capacity? And that particular demographic, of course, is going to move away very fast. So just as quickly as I have to scale up, I have to scale down. So the thing about cloud is that it has this idea of on-demand capacity, where you can, in a very, very short period of time, scale up very, very rapidly. But just as important, you can actually scale down again. So as those things are starting to change, as that need for capacity is starting to change, you can be responsive to it. Now, this isn't necessarily about scalability. It's about really being responsive to change and doing it in a very short period of time, not days, not weeks, not months, but minutes. And that's a very, very different approach to actually doing any kind of computing. Now, the way we do this, of course, is making use of economies of scale, of being able to replicate very, very cheap, inexpensive technologies like single board computers and things like that, and just replicating them en masse, and then being able to host many, many, many applications across that. There's an old joke about, the loneliest man in Google, and who's the loneliest man in Google? Well, it turns out the loneliest man in Google is the guy that actually runs around and just pulls out boards in the Googleplex that have died, throws them into the trash bin, and just puts in a new one. Google doesn't try to debug the boards or anything like that, simply because they're so inexpensive. They've pushed the price of those things down so much, and their compute capacity has no dependencies on any single device there. Google is always up. When have you ever gone to do a search on Google and not have it come instantly back? It never happens. And if it does happen, it has nothing to do with Google. It's probably your connection to Google that's actually gone down or something like that. That's a fundamental idea of cloud, that you can get tremendous economies of scale with very, very cheap equipment and have no single dependency on anything. Now, of course, it comes with a cost. It comes with a cost of multi-tenancy. In other words, lots of people using the same technology and moving around, not having any locality of reference on any single device. But there's ways of dealing with that. And I think one of the things that you'll see as you go through cloud is that there's pluses and minuses with everything. Now, elasticity is another piece that's very related to on-demand, but a little different. Because elasticity has this concept, really, of being able to very, very quickly expand out to be able to deal with blips in capacity or blips in the need for capacity that happen naturally in any kind of e-commerce site, any kind of real, potentially popular web technology. Now, really, this is something that we haven't been very good at dealing with in the past. We haven't been good at designing our applications to be able to be very responsive to changing conditions. We over-provision, and we try to hope that we've over-provisioned with enough of a buffer so that we can actually deal with all of this change. Really, elasticity is about quickly being able to expand to deal with that change. So fundamentally related to on-demand, but much more here related to the fact that it's about the technology itself and about being able to deal with that. Here's another characteristic, self-service, that is actually often overlooked in a lot of discussions about cloud. But I think really self-service is also about scaling. But it's not necessarily about scaling of technology. It's not about scaling of computers and things like that. Self-service is about scaling with people. It's about actually enabling everybody, all of the people on this call, the people that are sitting beside you in your offices. It's about really empowering them to use these technologies. It's about smashing the conventional, priesthoods, smashing the conventional silos in that we've seen in IT in the past, and instead enabling everybody to get access to these resources. Now, if that sounds impossible, it turns out that it's not really. Really what cloud is about in a lot of ways is giving people, empowering people with the ability to actually do a lot of their own provisioning and build a lot of their own applications out on a third-party service. And that can actually be a very, very powerful thing. Now, if we step back and look at the really good cloud applications out there, whether it's something like Salesforce.com, Google Docs, any one of these software as a service applications, and hold that thought in your mind because I'll talk more about that in a little while. But one of the key characteristics that they've actually done is that they've really right-sized themselves. They really understand the problem that they're trying to solve. They really understand their audience, the people that they're trying to sell to, and that they haven't overcomplicated their applications. In other words, they've got a very, very good alignment between the real business need of that person and what they can actually provide. If I look at something like Salesforce.com and I compare that to the CRM systems of old, I see something that's very different in terms of how it delivers things. Salesforce doesn't give you 50 different ways of representing an integer. It's not over-parameterized. It understands the real fundamental business problem that it's trying to solve, and it just hits that with a really nice application of the 80-20 rule. In contrast, if I look at a lot of the old CRM systems of 10 or 15 years ago, and many of these are still with us today, they're horrendously complicated. They try to parameterize everything, and they competed by parameterizing everything. And so what you ended up with was a very, very difficult application to use. It wasn't an application that was for the masses. It was an application that was for the priesthood. It was an application that were for basically the people that really spent a lot of time going into it and could, well, quite frankly, make a lot of money consulting in it, maintaining it, keeping it going. So it was a very self-perpetuating problem. So you had an us and them sort of situation. In other words, the people that maintained and kept that thing going and kept it running, and the people that were actually using it. The difference between cloud is that cloud and a lot of the best cloud applications have a much better alignment between the technology and the accessibility of the technology to the people that actually need to access it. And they've done that by aligning themselves very, very well with the needs of those people and surfacing just what those people need. Yeah, sure, there's always things that you wished you had on any one of these SaaS applications. But the fact is, you might wish you had it, but you probably don't need it. And if you did have it, it just overcomplicates the problem. I think cloud is really good at that kind of right-sizing. And one of the ways it does it really is through this idea of a curated stack. So in other words, it's gone through, and rather than try to integrate with a million different versions of fundamental infrastructure, whether it's queuing systems or databases or firewalls or, whatever, all of the fundamental building blocks of applications and networks and IT that we use every day, it's kind of come up with this very uniform approach to this. And out of that, you get a tremendous economy of scale, but a tremendous simplification. So much time is spent in IT dealing with inconsistencies and problems between our different silos. Integration has become a huge problem. But the thing about cloud is it says all of the fundamental building blocks of IT should just be made uniform. Let's solve that problem once and then let everybody use that, everybody come to that, whether it's how the database integrates with the directory or how the application server integrates with the database. All of these things, if they're set up for you ahead of time, if somebody else has dealt with the problems of those minor integration issues, and you've got uniform versions between every one of these, and patches just quietly happen in the background so you don't really have to worry about it. Somebody else has dealt with those headaches. That's tremendously powerful. That's something that actually all of a sudden changes the approach to IT. Now here's another thing that's a characteristic, I think, of cloud that people don't often look at, but I think it's actually really important, and that's a heavy leverage of open source. Doesn't necessarily mean that, of course, all clouds are going to be open source. If you look at companies like VMware, they're going to make a tremendous amount of money, not necessarily using open source, but using proprietary technologies. They happen to have some very, very good ones, and those have a real place in all of cloud computing. But what we also see in cloud is sort of a legitimization of open source on a mass scale that we've never seen before. You could not do a lot of what, let's say, an Amazon.com does, or I would imagine what, let's say, Salesforce does, without leveraging open source a lot. In my company, Layer 7 Technologies, where we actually build technologies to help secure clouds, to help integrate with clouds, as you're going to see in a moment, we actually make tremendous use of open source. We don't go through those questions of, is open source going to be a problem or not? Is it going to be, are there going to be issues with legality and indemnification down the road and things like that? We've accepted fundamentally that these are solved problems and that open source is a legitimate part of how we build applications. And that sounds like something like an overnight revolution that's taken 10, 15, maybe even 20 years. But the fact is, I think we're there now, and I think cloud is one of the greatest legitimizations of that. And finally, the last thing that I want to talk about, the last really important attribute about cloud that I think people often don't get when they first go in there, is that cloud changes the way we architect applications. And I think it demands a certain different approach to how we build applications. Cloud, for instance, comes to us and says, rather than putting a conventional database out in a cloud application, a conventional relational database that we know fundamentally can't scale up to the kind of activity that and the kind of mass scale that we're going to be expecting from it, why don't we look at the problem of persistence and sort of reinvent it, reinvent a solution around it that instead the primary focus is mass scalability, mass redundancy, so we don't have systems falling over, so that we don't have any single points of failure, so that we can actually have access to the data in all sorts of different deployment patterns. And I think cloud at its best does exactly that. Cloud doesn't try to take a conventional idea of relational databases and try to scale it up big. Instead, it comes out with something new like Dynamo or Cassandra or Bigtable or any one of these kinds of new, highly scalable approaches to doing databases and says, if you can just accept this slightly different approach, you win in these other ways. You win by getting tremendous reliability, tremendous scalability that you couldn't dream of before using conventional relational databases. And sure, you may lose the idea of complex joins from SQL, but if you just stop and ask yourself, did I really need that or not? All of a sudden, and if you accept that maybe you didn't, you can start to make really, really good use of this new resource. And so I think smart cloud applications, smart designers of cloud applications accept this. They get into this idea of architecting differently. Okay, so those are my big attributes. Those are the things that I think are very, very strong attributes of cloud. And obviously, a lot of them may have nothing to do with cloud, but they show up in cloud again and again. And so if you take them as a whole, if you take that collection of characteristics and attributes that I've been talking about, you start to get an idea of how cloud is different from conventional IT. Now, let's talk quickly about, I think, the models of cloud that we see again and again, because I'm going to talk about these quite a bit as I go through and talk about the integration problems. So let's get these down straight. Software as a service is this idea of the conventional website, if you will, but providing a very, very valuable service that's on demand, that's highly scalable, that has a curated stack of applications and that. In other words, has these characteristics that I've been talking about, but provides a very, very valuable service where you really only pay for what you need. And when I look at this, and I look at the good examples out there of this kind of thing, I think the ones that really typify it are the ones I've already talked about. Salesforce.com, or let's say Google Docs. These are excellent examples of software as a service. You have a lot of people that just look at them and say, well, it's just a website. It's no different than what we were doing 10 years ago, 15 years ago. But fundamentally, if you look at how that service is delivered, how that service is charged for, how that service is aligned with business needs and that, you get a very, very different approach. And that really is what typifies software as a service, which is a very important cornerstone of cloud. Now, at the other extreme, I have this idea of infrastructure as a service. And this is really typified by something like Amazon's EC2 or Rackspace or Terramark or any of these providers that are essentially giving you access to raw compute horsepower where you can run virtualized images on. Virtualization is probably one of the greatest revolutions of computing in the last 10 or 15 years or so. In our group here at Layer 7, we could not do the job we do without using virtualization every single day. It's fundamental into how we actually build applications now. And really the recognition that virtualization actually allows you to package up apps around into very, coarse level instances and create lots and lots of them, create lots and lots of running instances of these things is actually a very, very profound idea. And so infrastructure as a service is really this concept of actually starting to take this idea of mass virtualization and make it available on a scale that is unprecedented, something we've never been able to imagine before. And again, it utilizes economies of scale. It utilizes lots and lots of cheap equipment, and it's very, very on demand. You pay for what you use. Very, very interesting idea. Now, in the middle, we have something called platform as a service. And I always actually, sort of deal with software as a service and infrastructure as a service first, because I think those are the two extremes. The idea of a web application that's delivered as a service versus infrastructure as a service versus virtualization as a service. But in the middle, there's an interesting common ground. We have a little of both of those. You have an environment where you can actually start to build and deploy applications, but where the infrastructure that supports that, databases, application servers, queuing systems, file systems, are all actually brought together and made available to you in a curated stack. So in other words, all of those pieces are there. You don't have to worry about the integration of those. And if you're a developer, that's actually very empowering, because let's face it, it's one thing to get your system up and going and have it running on your laptop, but once you actually have to move out and replicate that again and again and again in a production environment, that can actually be tremendously difficult. So platform as a service is this idea that we can actually create all of this different infrastructure and somebody else deals with it. Somebody else gets it up and going and worries about the integration and worries about the day-to-day operations of it. This is one of those things that I think has been overlooked a lot, but is going to be the future in a lot of ways of cloud computing. This is going to be one of the biggest instances of cloud computing, one of the most popular instances of cloud computing. I think a lot of companies realize that. Microsoft certainly does. Its Azure initiative is really fundamentally platform as a service. If you look at things that VMware is doing with VMforce, which is an integration of SpringSource and technologies that are owned by VMware, and the database that's actually the fundamental component of Salesforcecom. Bring those two things together so that you can actually do Java development going against the Salesforcecom database. Profound idea, very, very powerful stuff. That's platform as a service. And that's where the kind of thing that we as developers are actually going to be deploying on, because we don't want to worry about application servers and things like that. Let me tell you, as a developer for a lot of years, that kind of stuff is a pain to deal with. So we've got infrastructure as a service, we've got platform as a service, and we have software as a service. But what does all this mean about to the enterprise? How do we actually start to utilize our existing technologies so that we can actually integrate between those things and our existing technology? Remember my initial stars of this show, my legacy app, my existing identity stores. How do I start to bring these things together? So it's not a question of us and them. It's not a question of new technology and old technology. It's instead a new way of doing IT, which actually integrates all of this kind of stuff together. So first, let's look at software as a service and think fundamentally about how we can actually start to integrate those existing pieces of data, those silos of data, whether it's integration of identity or integration of existing data sources. How can we actually start to make use of those in a software as a service sort of environment? So again, I'll pick on two that I think are really great examples of software as a service, Google Docs and Salesforce.com. So if I look at my drawing right here, that's me right there, that little blue guy down there sitting in the enterprise. And I'm hiding behind my firewall, and I'm out there browsing, and I'm a user of Salesforce.com. I'm a user of Google Docs. And the truth is, I do use these things all the time. I think they're great applications. They really excite me all the time. And I think they're great examples of what you can do in the cloud and how far you can push these kinds of ideas. But here's the problem. Let's zoom in on there on Salesforce.com and ask ourselves a couple of questions. Number one, Salesforce.com does a really good job of actually selling itself to end users. It sells itself to, well, salesmen in that. It knows that salesmen are probably the people that are going to be using it every day, and so why doesn't it market directly to those individuals? Maybe not the VP of sales, maybe the guys in the field who are actually carrying the bag, dealing with customers on a day-to-day basis. It's saying to them, come out, I'll give you all the stuff that you really need. Your IT department may be, promising you this for years and years and years and not delivering. Here, I can give it all to you right here. It'll take you 5 minutes to get out there and create an account and begin to load your data into the database and everything like that. And boom, you can be completely independent. You don't even have to tell your VP of sales. And in fact, that happens a tremendous amount of times. It's astonishing how many organizations don't even realize that their staff are using software as a service applications. It's often a shock when they find out that in fact, not only are 1 or 2 of their staff, but dozens and dozens of their staff actually using these kinds of things. But in this, you can start to see where the problems arise. Salesforce.com is a completely integrated system. I mean, it has its own directories. So when you sign up, you go into that directory, and it records, well, your credit card number for billing purposes, your name, your address, all that kind of stuff. It has a database. In fact, its biggest value is that highly scalable database in the sky that has all of your customer information. And it asks you to sort of put that stuff in there. It asks you to start to take those customer records and put them there, out there in the cloud. And that's not necessarily a bad thing. It has to be self-contained to be able to be, easy to use and to get out there and promote that ease of use so that it can sell to all of those end users and that. But when you think about it, you already have a directory. Hell, you already have databases and customer information and that. So you can get so far with this. But very quickly, you need to start to ask yourself this question. How do you start to leverage your directory that's already out there? The last thing that you want as an IT manager is a lot of different accounts out there on these SaaS applications which simply replicate identity again and again and again and again. You have a directory already that has a Scott Morrison identity in it. So how can you use those credentials, that Scott Morrison identity, and leverage that out in something like Salesforce.com or Google Docs or any of the other hundreds of SaaS applications that are starting to appear out there? Well, it turns out that there is a really good solution for that, and most of the good SaaS apps are actually very good at facilitating this. They recognize that a lot of organizations, as they begin to move out on a mass organizational basis instead of an individual basis, want to be able to make use of their existing identity assets. And it turns out that there's a number of protocols, like SAML, that have actually been developed over the last 10 years or so that are very good at doing exactly this kind of brokered trust. There's one important piece of the technology puzzle, though, that you really need to add into your networks, and that's something called a security token service. And what the security token service, or STS, does is it integrates with your directory and actually issues tokens, SAML tokens, that actually describe, in most cases, an active authentication and maybe some attributes about that individual. So if I look at my picture right here, me as a little blue guy, the first thing I do is maybe sign on to my security token service. So I put in my credentials, you know, S. Morrison and my password 123 or whatever it happens to be this week. And by the way, that isn't my password, just in case you were wondering. I mean, God, this guy thinks he's a security guy. He's using a short, you know, ridiculous password. But I sign on to that that device, and what it does is it integrates with my existing you know, directory or identity and access management system, and there are many of them out there. There are many different flavors of those, and it should integrate with any one of those. And what it does is it issues me a token, a SAML token that I can then use to get onto a third-party SaaS application, like Salesforce, like Google Docs, like any of the other ones out there. So this is an important piece of the puzzle, because I can leverage my existing investment by just dropping a new piece of technology, a security token service, into my network. And I can instantly leverage that so that every single one of my identities is suddenly relevant, potentially, out in Salesforce.com. Now, obviously, I need to provision those identities out in Salesforce too, and that's another step that I won't go into a lot of detail here on, but suffice to say, the key piece that you need here is that infrastructure to do single sign-on, that security token service. And of course, that's something that we at Layer 7 actually provide. I'll talk more about that in a few minutes. Now, here's question number 2. As you start to do more and more design out there in the cloud, as you move towards platform as a service, or as you move towards infrastructure as a service, where you're not just using sort of screen-driven templates and things like that, which are very, very common in SaaS applications, but as you're maybe developing more sophisticated applications that integrate with different databases out there, eventually you get to that point where you need access to the data that's locked up behind your firewall. And when you think about that, that might be a mainframe. You might have a mainframe data feed that isn't going to move out into the cloud very soon. I mean, that mainframe's been there for 25 years. It's a mission-critical part of your business, and it isn't something that you can actually just rip and replace and throw out into the cloud very soon. It's going to be here, possibly for another 25 or 30 years. So how can you leverage it? How can you somehow allow cloud applications that you're developing to safely and securely call that mainframe and get access to that system of record data, in other words, that master database? And the big problems that you face here are security problems of how do you secure that transaction as it crosses the internet, because of course in a lot of cases it is doing that. It's going across a public internet. And then how does it actually get into your network? How does it break past your firewall maze that you've created? How does it get through the DMZ? How does it know where to route itself to get into the mainframe? And furthermore, how can you protect that mainframe so that you're not being actually hammered from, let's say, a denial of service attack from out on the internet? The last thing you want to do is be wasting very, very precious, valuable, expensive mainframe MIPS on some kind of denial of service attack that's coming from halfway around the world. You need a way of doing threat detection on all of these different calls that are coming in, to ensure that only the legitimate calls from the legitimate applications that you have out there out in the cloud are actually able to get access to that mainframe. Now, of course, I talk a lot about mainframes, but that could just as easily be, let's say, an Oracle database or a DB2 database, or even an application that you've created over the last year or two that has become very important, very mission critical, that isn't necessarily going to move out into the cloud. You've got lots of those. So how do we do that integration? And the way we do it really is to start to think about an on-premise gateway that actually brokers queries, brokers communications between the cloud and between that back-end data source. And this is something that can actually deal with everything from the confidentiality management to make sure that, for instance, those transactions are using the right kind of encryption. They're using the right kind of digital signatures so that you've got integrity protection of any kind of communication that goes out over the public internet. It deals with authentication and authorization. It deals with audit, so you know who's accessing what and when. It deals with threat detection so that you know that any transaction coming in there has been scrubbed to make sure that it doesn't have any viruses in it. It doesn't have any onboard attacks against, let's say, XML parsing infrastructure and such. It knows how to route a message that comes in that's passed all of those different tests into the mainframe. It knows how to make sure that the mainframe isn't overwhelmed with activity so that it can actually do traffic shaping. It can hold back transactions to ensure that that mainframe never gets more than, let's say, 5,000 transactions a second coming in from this hugely successful new cloud resource that you've actually created. This kind of device is actually a very, very important part of actually integrating between your existing back-end data sources and the cloud. And this kind of brokerage of trust, this kind of brokerage and integration of data is actually a very, very important new role that's actually now being recognized as a cloud broker. It's an actual device that really adds value into the view of cloud resources. So think about this. Any one of these different systems out there, whether it's Salesforce, whether it's Google, VMforce, Amazon, any one of these great new cloud services out there still has value that can be added onto it at a local level. You want to have a localized view of all of those different services, localized management of those services, so that you as an IT manager, a security manager, what have you, really has control over who's accessing what and when. A lot of people talk about cloud brokers really as these things that do automatic cloud bursting or switching between different clouds and things like that. And without question, you can do that kind of thing with a cloud broker. The truth is, though, my personal feeling about that is that yes, people will do a little bit of that, but the truth is business doesn't do that kind of thing too much. I mean, think of how many relationships you have with third-party suppliers where you have backup suppliers and you're constantly switching back and forth between those. Whether it's, the supplier that gets you, stationery or something, or the people who are doing your check processing or your payroll. How often do we flip-flop back and forth between different instances of those? The truth is not very much. We might have a backup where if there's some kind of disaster that we can flip over to. But it's very rare we sort of flip back and forth between those different services simply because setting them up and dealing with the integration from a business point of view, from a technical point of view, is actually pretty hard. So the truth is I don't think there's going to be a lot of flip-flopping between different services. I think once you get into a service, you get pretty entrenched. So instead, I think the real value of a broker is providing services like I'm describing here, providing services like single sign-on out to those devices, or sorry, out to those different systems, providing services like integration to allow them to call back into your organization. A broker can switch between different instances. It can deal with things like the disaster recovery switches if one of those systems fails and that. But I think that's going to be more of a second or third order problem. I think the first order problems are the ones I'm showing you right here. Now, one of the greatest proponents of cloud brokers is this guy, and a lot of you probably know him, Daryl Plummer. He's actually a research fellow out at Gartner. And Daryl's been talking a lot about a really interesting new extension of cloud brokers. Because one of the problems he started to see again and again is he saw a lot of companies going out there talking about brokerage technologies, talking about the whole process of brokering, talking about what it means to be a broker and everything like that. But he also saw a lot of confusion in the technological descriptions of what people can do. And so he came up with a new idea, a new concept recently called cloud streams. And I think cloud streams is actually very interesting because what it does is cloud streams encapsulates the connectivity between a particular instance of a cloud and the local broker. And really what it does is, in a lot of ways, it up-levels the discussion in a way that stops too much discussion about the low-level mechanics of integration. In other words, all the muddy stuff that we get involved with in terms of how an integration happens. What kind of SAML token are you using? What attributes are important in single sign-on? What's the security model for querying back into a particular mainframe data feed? How is the data organized? Are you doing JSON schema validation on it? In other words, all of these multitudes of different technological details, all of which are important, all of which need to be there, but aren't necessarily important to the business. So in other words, the minute you start talking to the business about all of these difficult, low-level issues in any kind of integration, the eyes start to glaze over. Cloud Streams instead encapsulates all of that into a concept that it's like a pluggable template. You get a cloud stream for Salesforce.com. You get a cloud stream for something like Amazon. You get a cloud stream for something like VMforce. And these are pluggable templates really that encapsulate within them all of the details of integration, whether it's integration for SSO, for single sign-on, or integration for callbacks between those applications and the core information that resides within your existing enterprise. So really, cloud streams are about up-leveling that discussion. They're about a pluggable approach to actually taking cloud broker technology and making it be able to integrate effectively between your enterprise and every one of these different systems out there. And of course, this is one of the things that Layer 7 has been working on for quite a while now. We have a technology that we call CloudSpan. And CloudSpan is fundamentally a cloud broker. It's a device that actually sits within your network, like I'm showing here in this diagram, that you can plug cloud streams into. CloudSpan essentially is a generic broker in that it can talk to any one of the different systems. It's fully configurable so that if you have any kind of odd challenge in integration, and we all do, of course, you can get in there and start to tune it very specifically between your data sources, and you have very particular data sources that nobody else has, and a system like Salesforce or VMforce or Amazon or any one of these other cloud systems out there. But it also allows you to plug in very particular cloud streams, which are basically those templates that actually describe exactly how you can do that effective integration. So Layer 7's Cloud Connect technology really is about connecting the enterprise with the cloud. And as a part of that, we have each one of the different cloud streams, and we're working on more of them all the time, that actually allow these connections with every one of those different systems out there. So with that, what I want to do is thank everybody for being on the talk. We've been basically going over a lot of the new ideas here in what cloud is about. But the important thing that I want to leave you with is cloud should never be viewed as a replacement for the existing technology you've got. Cloud is a new idea that augments it. Cloud is really another, arrow in the quiver of IT. It's another important piece of this whole IT puzzle that I think all of us are going to use. People, in a lot of ways, aren't going to be able to resist what's out there in cloud because, quite frankly, it's just too fundamentally compelling. So what we've got to really understand is how we can leverage cloud well, how we can leverage it, control it, bring it onto our terms. And so Layer 7 is going to be working on technologies that actually give you exactly that. And products like Cloud Connect, which is part of our CloudSpan series of offerings, are available today. And they actually allow you to make use of clouds right now. So with that, I'd like to thank everybody for joining me this morning. My contact information is right here. By all means, if you're interested in talking about this more, contact me anytime, and we can talk about cloud brokers, cloud streams, and Cloud Protect from Layer 7 Technologies. So thank you, and have a really good day. Bye-bye.